All right, everybody, welcome to the video for lesson number 2. We will be describing the center of distributions in this lesson. In lesson 1, we learned how to take data, put it into bar graphs, put it into dot plots, and today we're going to dig a little bit deeper into what those graphs and things are showing us. So in the opening exercise, it says describe the shape of each of the following distributions. At this point, you should pause the video and try and describe these two distributions as either being normal, skewed left, or skewed right. Awesome. Hopefully you were able to do these two. Let's take a look. So for this first one, if you look, all of the bars, for the most part, are tallest to the left. So these upper numbers are skewing the center of the distribution to the right. So this would be an example of a skewed right graph. For the second one, if you look, the highest bars are in the middle. There are some bars on either side of it that are a little bit lower. So this would be an approximately normal curve. The question below says, what would you describe as the typical age for the distributions above? So typical would be like the highest value here. So it looks like the highest value for this one is somewhere between 5 and 10. For the second distribution would be somewhere between 50 and 60. Now, when we say typical, we're looking for like what would be the average age. Now, the average age is actually not going to be between 5 and 10 for that skewed right graph that's up there. The average is actually going to be a little bit higher. So this bar that's so high all the way over here to the left is actually going to skew the overall ages a little bit because of these higher ages like the 25 to 30 bar that's only one person. Like, think of it this way. If I asked everybody in classes what their age was, including myself, who's a very old human compared to all of you young humans, my age is going to take the average and make it increase. So what we have to do here is we look at these distributions and we want to try and find what's called the centers of them. There are two ways of describing the center of a distribution. We could describe the center of a distribution using what's called the mean, and the center of the distribution considering the median. The mean is the average of the data. We should know how to find the mean already. Finding an average, if I spell it right? Finding the average of the data, you're going to take all of the data pieces, add them up, and divide by how many pieces of data there were. The median is the middle value when the data is in order from least to greatest. So for this, we are going to use our calculators. And I'm going to go through some buttons and sequences of buttons that we have to use to be able to find some of this data in our calculators. And I'm going to have you kind of rewatch this section of the video if you got lost in your calculator. So if you get lost, just pause it, rewind a couple seconds, and you should be able to follow along with me in the calculator here. So number 2 says we will be using our calculator to complete the statistics, and we will look at this as a histogram as well. First things first, though, let's put this data into our calculators. So if we want to put data into our calculators, we're going to hit the stat button. We're in the stat unit, so we want to use the stat button. I'm going to leave it highlighted red for a second so you can find it in your calculator. And then there's a bunch of menus here. The first thing that pops up is edit. And edit allows us to put into a list of data. So if I hit edit, you're going to see list 1, list 2, list 3. You might even have some junk in list 1 if you're using an older sibling's calculator. If this is your calculator that you bought brand new, it's probably already blank. But I am going to go through right now how to clear your list. We'll do it again later if you get confused here. So on the new calculator, I learned this new trick the other day. If you just scroll up to where it says L1 and hit clear, and then go back down, it'll clear your whole list for you. If you already have a clear list, you could just start plugging in your data. So if you look, your data sample has multiple of the same number. You have to put every number in. So I'm going to put in 3 and hit enter, 3 and hit enter, and keep going through your list. So I'll put 4 in 4 times. The big thing about inputting data into your calculator is you don't want to miss a piece of data. If one number is wrong here, it's going to be a wrong number. So let's see how many sixes. 1, 2, 3, 4, 5, 6, 7 sixes. 1, 2, 3, 4, 5, 6, 7. For my sevens, I have 1, 2, 3, 4, 5, 6 again. 1, 2, 3, 4, 5, 6. I have a 16. That's a big number. 17. I have 22 twice. And I have 25. So the nice thing about the calculator, if you scroll up to your last piece of data, it tells you L1, and in parentheses next to it, it says 25. That's telling you that's the 25th piece of data that you inputted. So if you quickly count through there, there is 25 pieces of data, so that means we plug this in correctly. Now, just putting the list in is not the only thing we need to do. We need to calculate the data. So if we hit second and then quit, which is the button right to the right of it that says mode, I'll leave it highlighted for a second. It'll take you back to the main screen where you add 2 plus 2. If you hit stat again, and now we want to calculate something, so we will scroll to the right once. There's a ton of stuff in this menu, some of which we'll eventually use in this chapter, but for the first section, we're only going to use option 1, which is called 1var stats. 1var stats is where we have one variable statistics, which is what we have here. We have one set of data. So we're going to hit enter. On the calculator, L1 should already be next to where it says list, and then it's going to say frequency list. We didn't create a frequency list, so we're just going to skip that and go right to calculate. And if you hit enter, it should give you this list of numbers. So the first number has an X with a little bar on top of it. X bar is the symbol that we use for mean. So the mean of this data, which we call X bar, we are getting a value of 8.52. If we scroll down a little bit, there's an option there that says median. Notice it's on the bottom of my screen, MED. MED equals 6. So the median equals 6. So that means if there's 25 pieces of data, if I count up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I count up 12 from after that, there should be 12 above and 12 below the median. So again, the mean is talking about the average of all of your data. The median is talking about the middle of all of your data. All right, so now that we know how to use the calculator, let's take a little bit more of a step here and put it into a real problem that we can use. So it says a survey is taken by an insurance company to determine how many car accidents the average New York City resident has gotten into in the past 10 years. The company surveyed 20 people who are getting off of a train at a subway station. All right, the fact that we're just randomly choosing people getting off a stage makes this sample a good sample for us to take. You'll learn all about that though when you're in Algebra 2. For right now, we just have to take the data and put it into a dot plot or a histogram. So it says construct a dot plot that represents the numbers in the table below. So the number of accidents of 0 is 5 people, so we would put 5 dots above 0. For one accident, there was 8 people, so we'd have to put 8 dots above that. For 2 accidents, we would say 4 people. 3 accidents, 1 person. 4 accidents. One person and some crazy human had 11 accidents. One person. It also wants us to compute the mean of this data set, and then we can figure out a value that would represent the typical number of accidents New York City residents have gotten into, right? So if you look here, the shape, the general shape of what we have here is skewed to the right. Now, why do we call this skewed right? So in the first lesson, we just identified that this is the shape that we call skewed right. But we never really talked about why we're skewing it right. You might say, why isn't it skewed left? All the data is to the left, right? The reason why we say it's skewed right is because the center of the distribution is being skewed to the right because of this outlier over here. We call this point an outlier. It's a point that's so far away from the general points, it's causing the center or the average of the data to skew. So if we wanted to go through here and plug this into our calculator, instead of plugging in 0 5 times, 1 8 times, 2 4 times like we did on the previous example, we can create two lists. So I can make this list 1 and I can make this list 2. List 2 represents the frequency, right? This would be the frequency of our accidents. So when I plug this into my calculator, I'm going to go back into stat, I'm going to edit, and I want to clear that first list that we made. So I'm going to go up to L1, hit clear and go down. It should be an empty column now. And in L1, I'm going to put 0, 1, 2, 3, 4, and my crazy person that got into 11 accidents, right? We'll put 11 in there too. So that's the number of accidents is column 1. The frequency of each of those accidents, I'm going to put in column L2. So 5, 8, 4, 1, 1, 1. Your two lists should match in number. They should have the same number of pieces of data. So now when we hit second quit to go back to the main screen, we can now hit stat, go to calculate. We're still going to use one-var stats. But now, instead of leaving the frequency list blank, we want to make the frequency list list 2. To get L2 in your calculator, you hit second, and then the number 2. If you go to calculate, the same menu will pop up. It'll tell you how many pieces of data you have. It'll tell you what the average is. It'll tell you what the median is. It'll tell you everything. So it says compute the mean and the median. So the mean we have 1.7. The median is 1. So we could say the mean is 1.7. The median is 1. So what we can say is typically a New York City resident is going to get in about a 1 to 1.5, somewhere around there, of your number of accidents. The next question asks us to measure the center with the shape. So what we see here is, in this last problem, 1.7 is like here, right? You would expect, like, if that outlier wasn't there, the center should be really right at 1, right? Look at where the median is. The median is 1. That's the middle of the data. But the average of the data is slightly above that, again, saying that's why it's skewed to the right, right? The average is being skewed that way. So if you wanted to measure the center of your shape, right, the center of your shape here, that would be the center of your data. Normal curves, the center is right in the middle. When you have graphs that are skewed left or right, the center is going to be slightly towards where the higher bars are going to be, but being pulled towards the middle slightly, right? So like the highest bar here, that's the highest bar, so the center is going to be slightly skewed to the right here. This is the highest bar, so the center is going to be slightly skewed to the left there. That's all you really need to know about the skewed graphs. For number 4, it says, remember the 20 baby chicks from lesson 1 in the homework and their weights. Well, here are all their weights. Now, we want to go through and compute the mean and the median. The nice thing about us already creating a dot plot for this is it makes it easy for us to put it into the calculator. So if we put like our calculator, our L1 column is our weights, right? The different weights that we had for our baby chicks were 1, 2, 3, 4, 5, and 6. And if we make the L2 column the frequency of those weights, so there were 2 baby chicks that weighed 1 ounce, 3 that weighed 2, 5 that weighed 3. I'm just counting the number of circles or dots that we have, 3 and 2. So here's what I want you to do. I want you to pause the video. I want you to go back to your calculator and adjust your L1 and L2 columns and see if you can compute the mean and median for the baby chicks. All right, welcome back to the video. Hopefully you were able to do this. Let's go through it quickly in our calculator. So if we go to edit for our lists, we can clear our list for list 1, we can clear our list for list 2, and we can plug in some data. Again, I'm hoping you tried this on your own and you're just following along to check that you did it right at this point. So if we go back here and we quit, we go to stat, we go to calculate, we'll leave the frequency list in there. I'm hoping you got a mean of 3.5 and a median of 3.5. So it says, explain why these numbers are approximately the same using the shape of the data plot. Well, since the shape is normal, the center and the median and the mean are going to be the same number. So what we can say here is when the mean and median are the same, the distribution is normal. There's no skewing happening. So in the skewed graphs, the median and the mean are different values, and you can see how the mean is being skewed towards wherever those outliers are. In a normal curve, the mean and the median are always the same number. All right, number 5 gives us samples of 2 of Mr. Hines' classes and their scores for a certain test. It says compare the mean and the median for the 2 class periods. So you need to calculate some data here in your calculator. For these questions, I would not use a frequency list. So if you look at period 2, none of the students really had the same scores. There might be 1 or 2, but for the most part, they're all unique scores. So when I calculate period 2's data, I'm going to go to stat and edit. I'm going to completely clear list 2 and not put anything in it because I don't have a frequency to deal with. And I'm just going to put in the scores from this period. Again, making sure that you hit enter every time so that we don't have any missing pieces of data. We should have 10 pieces of data. If you quickly count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're good. If we go back to stat, go to 1 var stats, we got to get rid of the frequency list. There is no frequency list. And then hit calculate, we should find the average and the median right there. So the median was 24 for period 2. So the average score was, what was it, 23.6. And the median score for period 2 was 24. I'd like you to go ahead and take period 3's data, put that in L1, and see what you can get for period 3. So again, pause the video and try and type that all into your calculator. All right, welcome back. Hopefully you paused the video and you tried this. You're not just watching straight through. So if I clear my list and I put in the data for period 3, let's see. Again, making sure we don't miss any, double checking it. If one number is wrong here, you're going to get the entire problem wrong. Right? People always mess up when there's back-to-back numbers that are the same, so be careful there. And for this question, we should have 11 pieces of data, which we do. If you go into stat, go to one var stats. Again, there's no frequency list. We see that the average here, we'll just round to the nearest tenth, is 22.6. So the mean is 22.6, and the median is whatever that came out to be, 22. So it says, if someone did not study for the test and a score of 5 was added to period 3, describe the effect it would have on the mean and the median. Well, since 5 would be a very low score compared to all the other scores here, right? So if you take a look at all the scores, so if you put our distribution together, we have scores between 15 and 29. So you'd have all of these dots here between 15 and 29. If you put one random dot way over here where 5 is, what would happen to the data? Well, this would be a skewed left graph, meaning the mean and the middle are going to be pulled towards the left. So the mean will decrease, so will the median, but not as much. So I'll say slightly decrease. Again, because this 5 is an outlier, it's so far away from the bulk of the data that we have, it's going to adjust the center of the distribution. It's going to skew the whole graph. Where originally, without 5 in there, it might have been actually a normal curve. 5 in there makes it a skewed left graph. Hopefully this made sense. You can pause the video and try the homework assignment that's attached. It's just one page today. Make sure that you're trying the homework before watching the rest of this video. So again, you're pausing the video, you're trying the homework assignment, and then coming back to the video. All right, everybody, welcome back to the video, and I'm hoping that you all tried the homework assignment, and we are just in the process right now of checking our work. So for number 1, it gives us AP Statistics class student test grades, and we want to calculate the mean and the median. So for this, we don't need a frequency list. So we're going to go right into stat, we're going to go to edit, we're going to clear whatever junk we had in there, and we're going to type in some numbers. Somebody got a 42, somebody got a 47, an 83, an 85. Oh man, I put too many numbers in there. Let's go 83, 85 separate. There we go. 89, 93, and 95. We should have 7 pieces of data. 1, 2, 3, 4, 5, 6, 7. We go back to the main screen. We go to calculate, one var stats, no frequency list. And there is our information. We'll round to nearest tenth here again. So the mean here is an 80.6. And the median is 85. Which value is a measure of how the typical student did on the test? Explain your reasoning. So since the average is an 86, right, we could say that's a typical student, but actually the median is the better used statistic here because 42 is an outlier. So 42 being an outlier is going to skew everything to the left, right? So it's going to skew the mean to the left. So the median is actually the better statistic to use here. That's going to be more of what the typical student gets, not taking into consideration of one kid that probably didn't study. For number 2, it says students from this high school are randomly selected and asked how many pets do they currently own. The results are recorded below. So for this, I would probably use a frequency list when calculating the statistics in my calculator because there's a lot of the same number. So it says to construct a dot plot. So I should have 4 dots for 0. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots for 1. There's 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots for 1. For 2, I have 4. 1, 2, 3, 4. Lots of dots over here at the bottom. I have 2 dots for 3, 1 dot for 4, 2 dots for 5, 2 dots for 6. That's a lot of pets. 1 dot for 7, 1 dot for 8, 1 dot for 9, 1 dot for 10, and 1 dot for 12. So if you look at where the bulk of our data is, the bulk of our data is towards the bottom. So this is going to be a slightly skewed right graph. So it says calculate the mean number of pets in the high school and the median number of pets in the high school, and it will talk about what typically we have here. So if I take a look here, let me just scroll this over so I can make my charts here. So we'll go to stat, we'll go to edit. The first column is going to be the number of pets that people own. So I'm going to hit 0, a 1, 2, 3, 4, 5, 6, 7, 8, a 9. We have a 10, we don't have an 11, and we have a 12. The second column is going to be the frequency of each. So there were 4 zeros, there were 10 ones, which makes the most sense. 4 2s, 2 3s, 1 4, 2 5s, 2 6s, 1 7, 1 8, 1 9, 1 10, and 1 12. If we go back here into stat and we go to calculate one var statistics, make sure we include the frequency list for this one because there is a frequency list. You can say that the average pet owner is going to have 3.2 pets. The median is going to be 2. So typically we would say a typical student at this school has 2 pets. We'll use the median for this because these high numbers are skewing the average to the right. Hopefully that video made sense and you were able to do a lot of that homework assignment yourself. I will be back in school tomorrow and I should be able to help you out with any questions you had on this before we go on to lesson number 3. See you soon.